Okay, guys, here we go. We're going to take a little bit of a break from similar triangles today, and we're going to simplify square roots, also known as radicals. When we simplify them, we're also going to add them together and multiply them, and when we get to class, we will do some dividing. I will show you how to do that in class. Okay, so perfect squares and square roots. These things are opposites of each other. So 8 squared really just means 8 times 8, which is really 64. And the square root of 64 means what two numbers will multiply together to give you 64. Well, obviously we have 8 times 8, so this would be 8 times 8. Since I have two 8s, that's why it's called a perfect square and a square root. It's because that means there are two of them. So the square root of 64 is 8. 8 squared is 64. The best thing that you should do, honestly, is make yourself a table somewhere. Like 1 times 1 is 1. 2 times 2 is 4. So notice this is 1 squared. This is 2 squared. So 3 squared would be 9. 4 squared would be 16, and so on. I would make it till about 25 and keep that list very handy. All right, so let's look at simplifying radicals. All right, so obviously the square root of 24 does not fall into our list because we go from 16 to 25. There is no 24. That means we're going to have to simplify it, okay? So what we're going to do is over here to the side is we're going to go, okay, I've got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are all my perfect squares, okay? So I'm going to, or all my factors, sorry. So these are all the factors of 24. I'm going to pick the pair that has a perfect square. So remember that list I told you to keep handy? So I see that 4 and 6, because 4 is perfect. So that means that 24 is really the square root of 4 times 6. And then I'm going to break it apart one more time. The square root of 4 times the square root of 6. Since the square root of 4 is 2, the square root of 6 is a decimal, so I'm going to leave it just like that. So I get 2 square root of 6. So your exact answer is 2 square root of 6. Do not get these two mixed up. Don't do 6 square root of 2 because then you'll have it wrong. Okay, and then the decimal version, well, obviously you can go in your calculator and just hit the square root of 24, and you will get 4.9. Okay, now 32. 32 is going to be, I'm going to go over here and make my list. 1 times 32, 2 times 16, 4 times 8. 16 and 4 are both in my list of perfect squares, but since 16 is bigger, we're going to choose 16. So that means the square root of 16 times 2. So that means the square root of 16 times the square root of 2. Well, the square root of 16 is 4. The square root of 2 is a decimal, so I leave it alone. And that's my answer, 4 square root of 2. Type it in your calculator. You get 5.7. All right, so let's look at the square root of 50. The square root of 50 is, I'm going to go over here and make my list. I've got 1 times 50, 2 times 25. Oh, 25 is in my list. As soon as when you're making your factor list, as soon as you come across one that's in your big list, then use that. So this is the square root of 25 times 2. And I always list the perfect square first, so that when I break them apart, like this, it's always first. Oops. Square root of 2. So the square root of 25 is 5. The square root of 2 is still a decimal. So 5 square root of 2. Type it in your calculator, you get a whole 7.1. Now this one has a number outside. This means 3 times the square root of 28. So that means 3 times. So now I'm going to find my two numbers here. So 1 times 28 2 times 14. 4 times 7. So I'm going to go with 4 times 7. So this would be 4 times 7. So that means 3 times the square root of 4 times the square root of 7. So that's 3 times the square root of 4 is really 2 times the square root of 7. 3 times 2 is 6, and the square root of 7 is a decimal. So I've got 6 square root of 7. Type either one of these in your calculator and you get 15.9. I promise we'll practice more in class. All right, so this one, I'm going to go over here and do my factor list. So I've got 1 times 12, 2 times 6, 3 times 4, and 4 is the only one that has a perfect square. So this means 5 times the square root of 4 times 3. So that means 5 times the square root of 4 times the square root of 3. 5 times 2 times the square root of 3. 10 square root of 3. Type it in your calculator and you get 17.3. So when I say exact, I'm looking for this. Okay, this one, 1 times 200, 2 times 100. Oh, 100's in my list. So this means negative 7 times the square root of 100 times 2. So negative 7 times the square root of 100 times the square root of 2. Negative 7 times 10 times the square root of 2. So negative 70 square root of 2. And in your calculator, it's negative 98.99. And then the last one here, if you type in the square root of 96, if you made your list, you would see 196 is in that list, and it's really just 13. So this means 12 times 13. Well, 12 times 13 is 156. There is no decimal. Now, when you multiply them, it's real easy. When you're multiplying radicals, all you got to do is take whatever on the outside and multiply it together. Whatever's on the inside, multiply it together. So for example here, since both numbers are inside the radical, just multiply 5 times 2 is 10 and put the square root symbol back on. Done. This one is inside, this one is outside, so you can't multiply them. Your answer is just 3 square root of 2. You can only take what's outside together, what's inside together, and that's all you can do. So for example, this one, this is the square root of 6 times 5, but I know the square root of 4 is 2, so that's really 5 times 2. Well, 5 times 2 is 10, and then the square root of 6 is a decimal, so I leave it like that. You always want to put your square root symbol after a whole number. Okay, this one, I'm going to take what's on the outside. So 3 times 4 is 12. And then I'm going to take what's on the inside, and it goes inside, so that would be 40. Now, the only problem here is that 40 can be reduced. So I'm going to go over here and make my list. 1 times 40, 2 times 20, 4 times 10, 5 times 8. So my one with the perfect square is 4 and 10. So this means 12 times the square root of 4 times 10. 12 times the square root of 4 times the square root of 10. 12 times 2 times the square root of 10. 24 square root of 10. So your answer should be 24 square root of 10. All right. Now this one says give the exact measure. So they want us to find the area. Well, the area of a rectangle is the length times width. I know the square root of 9 is 3, so this really means 5 times 3, which is 15. So I know that my length is 15. I know my width over here is 4 square root of 5. Since the 15 and the 4 are both outside of the square root, I'm going to multiply that. 15 times 4 is 60. The square root of 5 is still there, so there's my answer. 60 square root of 5. Okay, now this one just means do this, whatever's inside, do it that many times. But first I'm going to notice here, I'm going to go, okay, first of all, the square root of 16 is really 4. So this really means 3 times 4 squared. Well, 3 times 4 is 12. And I still have my squared. And 12 squared really means 12 times 12. And 12 times 12 is 144. Same thing here. The square root of 36 is really 6, because that's in my list. So that means 6 times 6 squared. Well, 6 times 6 is 36. So 36 squared is, let's see, where's mine? So 36 squared is really 36 times 36, which is 1,296. And I don't know how number 15 got to be after 16 and 17, but they really got switched around. All right, so they want us to give the area of a square. Okay, well, if I have a square, so let's draw a square. So I have a square. Okay, and I know it's a square. All 4 sides are the same. And they tell me that this side is 3 square root of 4. Well, I know the square root of 4 is really 2, so this means 3 times 2. Well, 3 times 2 is 6. So that means all of my sides are 6. So if I'm going to give the area, it's length times width, well, the length is 6, and my width is 6. So that means 36. So my area is 36 units squared. All right, now we're going to add. When you're adding and subtracting radicals, just keep in mind it's kind of like adding square roots. I'm sorry, it's kind of like just, when you add square roots, it's just like adding x's or y's. You can only add things that are alike. So for example, this square root of 7 is alike this square root of 7. So you just add the numbers that are in front. 3 plus 2 is 5. So I have 5 square roots of 7. So if you have 3 and I have 2, then together we have 5. This one you cannot add because you cannot combine because they're unlike terms. So we're going to put cannot combine unlike terms. All right. Now, let's look at this one. There's really a 1 here, so there's really a 1 here. So if you have a square root of 7 and I have a square root of 7, together we have 2 square roots of 7. Ooh, that's an ugly 7. Now, if you have 3 square roots of 7 and I take 2 of them away from you, you really have 1 square root of 7 left. You don't need the 1. It's just assumed, kind of like 1x is equal to x. 1x is equal to x. 1 square root of 7 is equal to the square root of 7. They work just like variables. Now this one is a little bit different because you're going to have to reduce, you can't add the 12 and the 3 because they're unlike, so you have to force them to be alike. So let's force this to be alike. So I'm going to go over here and I'm going to go, okay, 1. Okay, let's see if this is going to work here. 1 times 12, 2 times 6, 3 times 4. So I'm going to choose the 3 and the 4. So that means 3 times the square root of 4 times 3. 3 times the square root of 4 times the square root of 3. 3 times 2 square root of 3. The 3 and the 2 are outside. 6 square root of 3. Now the 6 square root of 3 matches the 2 square root of 3. So now I can add 2 square root of 3, giving me 8 square roots of 3. So if you had 6 and I had 2, together we have 8. So now we're going to find the exact perimeter of a rectangle. So first thing I want is a rectangle. So I'm going to go over here and I'm going to draw me a little rectangle. And I'm going to say the width is 4. So 4 square root of 5. And the length is 5 square root of 9. Well, I remember the square root of 9 is really 3, so that means 5 times 3, so it's 15. Perimeter is 2 lengths plus 2 widths. So the perimeter is 2 lengths plus 2 widths. So the perimeter is 2 times 15 is 30 plus, since the 2 and the 4 are both outside, 2 times 4 is 8. Square root of 5 stays the square root of 5. I can't add them together because they're unlike terms. So there's your exact perimeter of a triangle, I'm sorry, of a rectangle whose width is 4 square root of 5 and whose length is 5 square root of 9 or 15. So that's the end. I will see you in class and we will practice some more.